We're looking down on the Volturno River in Italy, where the enemy has blown up many bridges to stall the forward movement of our troops. The results are vividly illustrated in these scenes, with the Volturno presenting an awful panorama of demolished structures. American engineers must push in swiftly and counter the delaying action by constructing new bridges for use by our advancing troops. Various types of fixed bridges are employed. And as we move in to show the first specific job, we find our engineers removing any mines that may have been left by the fleeing enemy. This is naturally of first importance. Now a surveying party makes use of the transit to lay out the center line of the new bridge. Next comes the preparation of the abutment. It is to be emphasized that all the scenes in this film were photographed by combat camera crews. They recorded every operation possible to shoot under the conditions. Engineers unload parts for a Bailey Bridge, a prefabricated portable structure already used extensively in this war. The panels shown here are part of the launching nose. They are held together by panel pins. Transoms serve as the supporting beams of the roadway. Before construction is completed, it's necessary to push the partly built launching nose out over the gap. Stringers are placed to support the chest. The latter are held in place by ribbons or curbs, which are bolted down by ribbon bolts in the manner shown. The bridge is then launched by manpower. The need for teamwork cannot be stressed too strongly at this point. The engineers completing the job have been trained in this particular type of work. They know just how to handle any situation. Finally, the new bridge is jacked down into place on its bearings, ready now for use. The Bailey Bridge may also be adapted to other construction methods. For instance, as a railroad bridge of the type shown, a 120-foot triple-double type supported at its center by the remains of a demolished pier. Those destroyed piers in the distance represent what was once a 1,200-foot bridge. Reconstructing the old bridge would be a job requiring too much time. So the engineers proceed as follows. Temporary bridges are built, such as this 140-foot triple single Bailey, reinforced by 4 bays of double-story construction. Floating as well as fixed bridges are employed. And here we see one of the temporary ponton bridges, built so that heavy equipment can be moved over the river. As for the new 1,200-foot bridge, it was constructed first as a single Bailey and launched by hand over rocking rollers on each pier. It was then converted to a double single truss. A problem of supply sometimes presents itself. The Bailey Bridge equipment is needed in a forward area. So, here a trestle bridge is built underneath the Bailey. The Bailey equipment can then be removed and carried forward for bridge construction elsewhere in the combat zone. No obstacle is too difficult to surmount. Right now, we see retaining walls being backfilled with rock to form an abutment. It's the beginning of an operation made necessary when the approach to a bridge has to be extended to shorten the length of the gap. The A-frame on the bumper of this truck is used as a crane to move logs and stringers into place. The retaining wall is tied into the bank by headers and guy wires, with railroad rails used to help hold the wall. Construction on the timber trestle bench goes on while the abutments are prepared. Local labor is brought in to help finish the job. The men are assigned to build masonry revetments around the bottom of the trestle bench. Protection is provided for the concrete while it's setting. They can relax now, for the bridge is ready. So the engineers carry out their assignments on many fronts, constructing countless new bridges with skill and speed.